Hello guys, welcome to Pepcoding, and today we are going to solve this question, gold mine 2. So if you remember, we have already done a gold mine 1 in our level 1 right now. Right, so now we are going to do gold mine 2. So first of all, let's understand this, that this question is very much similar to flood fill. So if you have done flood fill, then you will understand this question in a much better way. But if you haven't done the flood fill, then even then it's okay, you will understand this question. And this is a very, I will say, ideal and good question of recursion and backtracking. So just keep your mind here for some time and you will understand how you can do this gold mine 2 problem in with the recursion. Okay. So first of all, let's understand what the question statement is, and after that we will gonna solve. We will gonna understand the question approach, and then we just gonna code it out. It's very pretty much easy. So guys, what is? Let me take an example first. Let's take even this example. We have given an input of 2D matrix, or you can say a vector if you do it in C++. And yeah, in this code we will do it in C++. So we have given a 2D vector, which will look something like this. Okay, and what we need to find is we need to find maximum gold. We need to find maximum gold. This is the particular value of particular gold at that particular position, right? We have to find maximum gold by traveling in the grid. I'll call this 2D matrix as grid. Okay, so maximum gold by traveling in the grid, but there are some constraints. First is you can never visit a cell with zero gold. You can never visit a cell with zero gold. That means you can say that if a cell has zero gold, then you cannot visit it, and you also cannot cross it. Like I cannot say that this is a valid path, like 6504 you can visit like this. No, you cannot visit like this because there is a zero. You cannot cross this zero. So if there is any zero, that will work something like wall or boundary. So if there is any zero, that zero will work similar as wall or a boundary. Okay, two things are done. What we need to do, we need to find maximum gold by traveling in the grid. Second thing is I cannot visit a cell with zero gold. Now come to third point. You can start and stop at any point. So the thing is, you can start traveling from any point and you can stop traveling at any point you want. But the thing is, you need the maximum gold in that particular path. So for example, if I start traveling from this point and I traveled something like this, and I cannot go to this point, right? So I travel in a manner that I travel this, and this. And this is my path. If I'm giving this path, so this is the, so what is the maximum gold here? So here the maximum gold will be 4 plus 2 plus 8 plus 2, which is something like 4 plus 2 is 8 plus 2 is 10. 10 plus 2 is what? 12. 12 plus 4 is 16. Okay, so but the thing is, you cannot cross a zero. You can start and stop at any point you want, and you need to give what? The maximum gold in that grid. Alright, these are the main points of the question. Now let's understand how we will gonna do it. Now we will talk about approach. So if you have done flood fill, then it's a very similar question. Even in this question, you have to do the same thing. Okay, just wait for the second. Let's take a smaller example where I can show you a dry run also, because this is a very big example. So let's take a smaller example. So for example, we have given a matrix something like this: 0, 0, 6, 0, 5, 8, 7, 0, 9, 0. Okay, so this is the question matrix. This is our matrix which we have given, and we have to find the maximum gold by traveling in this matrix. All right, now, so for now what I need to do is, now understand this, the approach I'm going to use is DFS. I do what? I will start travel from every point. I will start my DFS traveling from every point, and I will try to get the maximum. I will try to get the maximum sum of every path from that point. So for example, I start DFS from 0, but I cannot start anything from 0 because 0 is a wall. So I move to this point. Now from 6 I will start my DFS, and from DFS I get like these paths. One is this, second path is this. If I try to put DFS here, these are the paths I will get. The third path is, this is also a path I will get. But at 6, what I will return? I will return the maximum of all of them. All of them. This is what I will gonna return. So if I return maximum at every point, I will return the maximum of every path possible from that point. When I reaches to till this point, I will return what? Maximum of every point, like path from maximum of every point. That is what I will return from here. So at the end, I will get the maximum. I will get the path from. I will get the maximum gold which I can get from any path of this matrix. All right, this is the basic approach I will use. Like I will use DFS at every point. But now there's one more thing. Like if I start from traveling from this point, and I make a recursive call to this point, at this point make a recursive point call to this point, what will happen? Here's the loop. They will keep running in loop, right? Like this is the loop, and if they keep running in loop, I will be dead. I will dead. So for that, what I will do is I will create a visited array. Same a visited boolean array. I will create that will hold the account at which coordinate of which point I have already visited. Alright, so let's make it. Okay, this is taking a little bit more time, but it's fine. Okay, now let's do our dry run. Okay, so first of all, we are at this point, and the thing is I cannot make any call to this. First of all, every cell here is filled with false. Like if nothing is used, nothing is traveled right now. So from here I make my call to, I cannot make a call, right? Because the thing is this is 0, so this is a wall boundary, so I just keep moving to this point. Now I'm at this point. I will do what? I will make my recursive call. First of all, I will make my recursive call to this point. So this is what? This is 0. 0 means it is giving nothing. So 0. I'll make my recursive call to 0 upper side, but this is what? Out of bound. So nothing here this side. But remember. And one more thing, if I visit this point, so first of all, what I will do, I will update my visited, like, and I will say like this point is visited. Now from this point, I'll have a choice to move to this point. When I move to this point, what will happen is I have to make this true also. So what? I'll make this point also true. Okay. Like I have visited this point. Now from this point, I have to make a choice. Like I can go to this point, or this point. For now, let's move to this point, like 5. So for 5, again I have to do the same thing. Remove this and make it what? Make it true. This is visited. Make it true. Now is the critical point. If you find a point from which there is no path available, so from 5 there is no possible way available. Why? Here is what? Boundary. Here is what? Boundary. Here is what? Out of bound. So there is no path, no place to make a call, right? So if there is no place to make a call, then I will do what? I will do backtracking. Now is the time to make a backtracking. So now what will happen is, from here I will start to go back. First of all, I will go back from here and I will return what? I will return 0 because there is 0. From here it will get what? 0. From here it will get what? 0. But now is a critical point. What we need to return from this point is, from any point, what we need to return is maximum of every call. Like here, there are three calls, which was left, down, up. Right? There was three calls for left, for down, and for up. So from all of the three calls, I will get what? I will take the maximum. Then from after maximum getting the maximum, I will add self to them, like from 0, 0, 0 plus 5. And this is what I will return from here. So I will return what? I will return 5 from here. And after returning from here, I have to do the same thing again. Let's go back and make it false. Make it false again. Like this is the backtracking part. Like this is the backtracking part. We have to return what? We have to get the maximum of all the calls and add self to that call, and again make our visited. Now from 8, I will make another call to 7. Okay, then what will happen? 7 will get true. From 7 again, they will make this call, this call, this call. But what? There is 0. But what? There is 0 from this side, 0 from this side, and 0 from this side. 0, 0, 0. So after getting 0, what will 7 return? 7 will return the maximum of this plus 7. So it will return 7. Now there's one more call which I have to make. And yes, from, before returning, we have to make 7 again to 4. Now there's one more call remaining, which is to 9. We have to make a call to 9, then again we will do what? We will make this 9 true. So make this true. And in this 9, then again I have to make the calls. So it will make call to this 0, and this. So again what I have to do is find the maximum. From here it will get 0, from here it will get 0, and from here it will get 0. So what is the maximum? Maximum is 0 plus 9. So what will it return? It will return 9. Now you are understanding that we are back again at our 8, point number 8. But now there is no more call left. We have already made the calls to every point. So now again it will backtrack. So before backtracking, now understand this is again a critical point. Please keep your attention here for some time. So what I will do is maximum of what? Left call, comma what? Right call, comma what? Down call. Maximum of all of 3 is what? Maximum of 5, 7, 9 is what? 9 plus self. 9 plus self is 8 is equal to what? 17. Right? So here it will return what? When there is a chance to return, it will return what? It will return, let's remove it. You have to return, it will return 17 from here. And also we have to again make it false. Now we are at this point. Now at this point, it is getting what? It is getting 17 from this side. Again, let's remove it. And let's do it again. Now we are again from our starting, back to our starting point. At starting point, I am getting what? 17, 0, 0. What is the maximum? Maximum is 17 plus what? Self. Self is what? 17 plus 6 is equal to 23. So at this point, what is the maximum from all the paths? From all the paths, the maximum is 23. And then again, we have to do what? We have to make it false. Again, have to make it false, and then it moved to this point. At this point, we got our 23. Like this is the maximum if we start from this point and go to every possible path. So understand this. Now what we are trying to do is we are trying to find the maximum of this, then from maximum this, from maximum this, from maximum from here, maximum from here. We will try to find the maximum from every point. last what we will get is maximum of every point we will get from here. Now we will find the maximum to everyone. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 blocks, so we will get the maximum from the 9, and that I will return. And that is what our answer is. That is what our answer is. Pretty simple. Let's move to coding part. So here we have to code our part which we have given. We are given n, m and vector array. Okay, now we have to get maximum gold in this function. Okay, we will do it right now. So what we will do here is, first of all, I will travel to every part, every single cell, because I have to make the call to DFS to every single cell, right? So I will do what? Int I is equal to 0 and I is smaller than what? Grid dot length. So let's make a variable for it. Int n is equal to grid dot size. Then int m is equal to grid of 0 dot size. After that I have to go through every point. So it's smaller than n and I plus plus. Then again for int j is equal to 0, j is smaller than m and j plus plus. Okay, this is done. Now from this point I have to create a vector of boolean which will be visited. I have to make a visited boolean, right? So I will create my visited here, and of the size of same as our grid, n vector boolean m comma false. Very simple. Now I have to make my DFS function. Okay, so for that I'll create my DFS function. So one more thing, if and only if grid of I, okay, I and j is not equal to 0, only at that point I have to make my call, like max gold is equal to max of max gold, comma get max gold underscore. Okay, so this is our DFS function. Get max gold is what our DFS function. Okay, and max gold is our just our, I'll say, a variable which is holding the answer. So int max gold for now is 0. So we will go to get max gold, and here I will pass grid, then I, then j, then n, then m, then visited. Simple, very simple. Now at last what I need to do is just return max gold. These things are done. Now let's talk about base case. What is the base case? So here, if grid dot size, base case, or I'll say just a condition that if grid dot size is equal to 0 or grid of 0 dot size is equal to 0. If to do what? Return 0. If we don't have any grid, what we will do? We return 0, because if there is no grid, there is no answer available. So this is done, this function. Now let's talk about our get max gold function. Control C. Now let's create this function. This is the main function, right? Because we have to go make our DFS call here. So int get max gold, then vector of int m% grid. We have passed a grid, then int source row, then int source column, then int n, int m, comma vector of vector of boolean visited, ampersand visited. These are the all arguments I wanted. Now let's talk about our DFS thing. This is important. Okay, guys. Well, again, make your concentration here. So first of all, what I need to do is I need to make my visited true. Then what I need to do is, in the second thing, we need to make a recursive calls. After that, I have to do what? Again, visited false. Right? These are the main thing which I need to do. And at last, I need to do what? Get max. Right? And also I need to do what? Add self. These are the main things which we need to do. So let's start doing them. The first thing is visited true. So let's do it. Visited. Source row. Oh, and source column is equal to true. Here I need to do what? I need to make visited source row and source column is equal to false. This is done. Now let's make your recursive call. So int left is equal to get max gold underscore, and here I need to send what? Grid comma source row comma source column -1, then n comma m comma visited. This is done. We have to make a left call, so we have to move a little leftward in the column. So I decrease a column, right? Then we have to make calls to every direction, right? After left, it will go right. Then it will go up. Then it will go down. So grid. Then here it will be source column +1. Then here it will be for up source row -1. Here it will be source row +1. These things are done. I make my visited true. Here I make my visited false. After that, what I need to do is getting the maximum and add self. Let's do this also. And answer is equal to max of left comma max of right comma max of up comma down, and plus grid source row and source column, and last what I need to do is return answer. I didn't do anything which I never told you, right? I have to do what? Visited true, recursive calls, visited false, get max, add self, return. This is what I did. Now let's talk about what? Base cases. Base case is also very simple. So if source row at some point in time will less than 0, or source column is less than 0, or source row is greater than equals to n, or source column is greater than equals to m, or visited of source row and source column is equal to true. If they are already visited, or grid of source row and source column is equal to 0. If there is any cases from them, what I have to do is return 0. This is done. Here I find our answer. Here I get our the maximum of every possible solution. And at last I need to print it, so you have printed it. Alright, now let's try to run this code. If there's any compilation error, we will gonna solve it out. Other than that, let's run this code. There is a compilation error, let's check it out. So we have an error at line number 10. Okay, at line number 10 we have this true, so let's put a semicolon here. Also at line number 17, let's put a semicolon here. Now let's try to run it again, and I hope this time there will be no compilation error. Yes, this is accepted. So guys, this is the perfect solution for our answer of gold mine 2. And if you understand this, if you understand how to do this question, if you understand my dry run, if you understand what is the approach for this question, please like the video. If you have any query left regarding this question, please comment it out and subscribe to our channel. Thank you so much, guys.